Welcome back, everybody, to the Outward stream. Today, we're doing exciting things today. So, last time, I told you that basically we had some goals, right? We wanted to be able to measure things a lot more accurately. Last time, we used arrows. Arrows are our new unit of measurement. Instead of the meter, we shall be using the arrow from henceforth on. Why? Because I want to. This view that we're looking at has a certain angle, right? And that angle isn't going to change. So when I'm looking at something, my eyes are always staying in the same spot because they're in my head, right? But our character does not have such an advantage. See, Veda's eyes may look like they're in Veda's head, but they're not. They're controlled by the camera. They're this, right? And it changes. Now Veda's eyes are closer. They're farther away, closer again. You know, kind of like how she's cross-eyed. Like, even though this shape is staying the same size, this angle has changed, right? And that's an issue. What we need to do is basically iron out the details of where we can measure things, because if we're associating a shape with an angle, our assumption here is that our eyes are staying still. So we can only make that assumption for certain ranges of the angle, right? How would we figure that out? Because we're not looking at the actual triangle when we're like moving up and down. We're looking at a projection. So, So we're not actually moving like the same amount up or down. Oh my goodness. I need to think. Just think about it. Give it a little think. Just stare at it long enough and it will start to make sense. I would have a bunch of right triangles. The reason I say right triangles is because look at this little trick. Yoink! 2 right triangles. It's almost like magic, but it's not, because it's science. We know that this angle is the same. So we know that angle is the same. The angle, but we don't have the angle here. That's the issue, because we changed locations. That tangent of 2 times 10, which is going to be the first. Well, it's times 2 too. Because we want the full triangle, right? That's going to be 0.7 arrows. 0.69. Nice. And we know this this length. And basically what we're assuming is that we're measuring nothing, right? We're measuring a lot of thinking, a lot of staring at the screen and making weird faces, scrunching eyebrows. Yeah. How do we get that length? How do we get there? Well, I know the 90 degrees, but you can't do the ratio of a 90 degree because it gets a little funky. That was something I didn't mention with the sine and the cosine, but we can talk about infinity later. Hello everybody and welcome back to the stream. Today is going to be a busy day because yesterday, or not yesterday, Tuesday, we found out that measuring height was going to be a lot more complicated than we once thought. Not impossible, but a little bit more complicated. So what we're going to end up having to do is we're going to have to basically create some code to actually generate that. Now I'm going to go over the math a little bit first. I didn't do much work outside of the stream other than thinking about it, just because I wanted to be a little bit more coherent as I was talking. But I'll go through with you guys everything that I basically saw and went through, so hopefully that will help. So I don't think we can, but let us come back to our notebook, because fear not, I think there is a way. If we look at our notebook, any object actually, because that doesn't care about the contours we met along the way, right? Those contours could be anything. The only thing we're concerned about is the distance between the top of our object and basically the base of where we started the measurement if it's an angle. So if we're talking about a mountain, we're basically going to have to go to the side of it and roll until we get the height. Or, in just a moment, we'll also come up with a handy dandy tip for basically calculating the large distances, so we don't have to roll hundreds of times across the map. As wonderful and entertaining as that might be. What are we doing next? What are we doing next? Well, I don't want to calculate this by hand every time I want to measure the height of something. So one of the things we're going to need to do is we're going to need to build an Excel sheet. Well, I say Excel, it's going to be Google Sheets, because guess what? Excel isn't free. Hence me not using it. 0.25 over 20 times 2 is equal to theta. Let's bring out the handy dandy calculator. Oh, I didn't even show you the notebook. There we go. That whole thing times 2 is going to be 1.43 degrees. Now, if you recall from last time, that's actually kind of what I was saying this was going to be. So, one rhombus slash square is equivalent to 1.43. We'll keep it at that degrees. Okay, so we now have our theta. We have our theta. That wasn't too difficult. So yeah, now we have basically our representation of what this is. So in the future, when we come back, we know exactly what is going on. But for now, we have an exciting new tool that we have in order to measure things. So let's go measure things. I am very excited. I don't know about you guys, but this is like peak performance right now. Absolute peak performance. In case you guys didn't know what peak performance looked like, it looks like this. So yeah, the pi functions returns the value of pi to 9 decimals. So that's better than what I was going to give it, which was just 3.14. It's not times 2 pi. I don't know why I multiplied it times 2 pi. I just told you that it was pi divided by 180. So there we go. Yeah, that's starting to look good. Yeah, okay. So, in case you didn't know, Veda is 2.6 arrows high. Isn't that just so tasty? You know, things that they put in the game that I feel a lot of people don't pay attention to just because, you know, why would you? Why are you a psychopath? God, why are you counting the scales on fish? Jesus. It is time to end the stream. Unfortunately. I hope your week is going swimmingly. If you've started school back up again, make sure you're getting on that homework. It's important. It's important, you know. You gotta prove to people that you're smart. So that they trust you to do things that they don't know how to do. And with that, I think I will say goodbye. Have a fantastic evening.